Today we're going to talk about graphing or sketching graphs of polynomials. So polynomials are equations. If you didn't know this, I know it's something that is introduced in 9th grade, but you may have forgot. Polynomial is an equation, but it is a specific equation, and there's two things that make an equation not a polynomial. So one thing that is not a polynomial is whenever you have an equation in which the exponent is a variable. This is an example of something that is not a polynomial. Another common example is when you have an exponent that is negative. Any negative number in an exponent position is an example of not a polynomial. But you've been working with polynomials probably since 7th grade. So when you first learned how to graph something like 2x plus 1, so that's a linear function in the form y equals mx plus b, that's polynomial. When you were introduced to quadratic equations, that's a polynomial. So when we think about equations, we're thinking about any type of equation, but there's a couple exceptions. One is it can never be exponential, so we never want the exponent to be a variable. And two, the exponent can never be a negative number. So we're going to make predictions about what is the graph's going to look like, and there's some indicators that tell us. First is the end behavior, and that means when we look at a graph, we're not looking at the middle, but we're looking at the far ends, and the horizontal far ends, the far left and the far right, and we can make a prediction of what's going to happen. So I'd like you to write down the following example in here. This says, by the way, make sure you have this out on your paper. It's going to be a tool that you're going to refer back to. This says odd degree and even degree. If you're not familiar with the words degree, I want to define that for you. The degree of the function means, I'm writing down an example here. It means when you have a polynomial equation and it's written in standard form, that means they line it up and they organize it really pretty. They put the variable at the highest exponent followed by the variable with the next highest. So in this case it's x to the third, x to the second, x to the first, and x to the zero. So when they line up and they make it pretty in standard form, we're going to look at what is the highest value in the exponent position on a variable. So in this case, we would say this is an example of degree 3. Let me move right back here and I want you to show you. This is a polynomial. How do I know this is a polynomial? Because I can see that the exponents are never negative and they're never going to be variables in the exponent position. So this is a polynomial equation, degree 4. It's lined up pretty in standard form, degree 4. Again, this is polynomial. How do I know this is polynomial? The exponents are never variables and they're never negative. This is degree 3. This is a polynomial, degree 9. This is a polynomial, degree 8. Thumbs up or thumbs down if that makes sense to you. You can define the degree. Okay, the second, when we define the degree, not only are we going to say what value it is, degree 4, degree 5, degree 9, degree 8, we're going to classify it as even or odd. It seems very simple because you learn up the words even and odd in elementary school, but let's review those. Even numbers are 2, 4, 6, 8, and so on. Odd numbers 1, 3, 5, 7, and so on. So in this column, moving from left to right horizontally, if something is odd degree, it's going to be an example. This is odd degree. 5 is the degree, it's an odd number. This is even degree. Before is even number, it's degree 4. This is degree 9, it is odd. This is degree 8, it is even. Thumbs up or thumbs down if that makes sense to you. Okay, so this is all going to lead up to helping us make predictions about what's happening at the end of the graphs when we sketch this without using a graphing device. That's the first thing we need to review. The second thing is leading coefficients, and I think you're probably even more accustomed to seeing that. Once we put it in standard form, we're going to look for the value that is in front of the variable with the highest value. So this is already lined up. This is degree 3. What value is in front? It is a 5. So coming back over here, they are all lined up beautifully. This would be leading coefficient 3, leading coefficient negative 2, 1/2, and negative 8. We're going to identify the leading coefficient, and then all we need to know is that value positive or negative? Okay, now I'd like you to draw the arrows that I am drawing. Please draw the arrows. This is going to be draw up on the right, down on the left, up on the left, down on the right. It matters what boxes these go into. I personally like to think of this as a person and those are their arms. That's me personally, and if you were in my Algebra 3-4 class, we practiced this last year with arms. Arms up, left, up, right, up, both down. This has to be on your paper. We're going to use that. So we are going to practice this right now. When we think of end behavior, we're not looking at the middle of the graph. So if this was an entire graph right now, I would cover up the middle, and all I'm wondering is on the far right-hand side, what's happening? Is it headed up? Is it headed down? Or is it staying horizontal at some value? On the far left-hand side, is it headed up? Is it headed down? Or is it staying horizontal at a value? So let's look at this, and let's make a few predictions right now. You do not have to write down these examples. We're going to look at A through D together. So if this was your paper, what I would like you to have you do, so Noemi, perfect, you can go sit by Noemi, please. Just go sit by Noemi. What I would like to have you do, and you're welcome just to watch for the purpose of time, and I will record this as I will post this for anybody who needs to rewatch this. The first thing I'm going to do is I'm going to make sure that it's all lined up in a standard form. Okay, that looks beautiful. Good. The second thing is I'm going to circle the degrees. So this is degree, and next this I'm going to write the word even because it's an even degree. Then I'm going to take a rectangle and I'm going to box in the leading coefficient. And above that, it's not even or odd that I'm looking to do. I'm going to write positive, and I'm going to abbreviate. So this should be positive is up on the right and down on the left. Negative is up on the right. No, this is all correct. This is even. Oh, these two are switched. Thank you. These two are switched. Thank you, Noemi. Please switch yours on your paper. Thank you, thank you, thank you. All right, so here we go. So I again have identified the degree, and I'm going to classify it only as even or odd. Then I'm going to box in the leading coefficient and write positive or negative. Damien, you're going to take the next person that comes in, okay? Okay, now I'm going to come back over to this chart. Right now I'm going to make myself a very small graph, and all I need you to do is watch right now these first 4 examples. Okay, so I'm looking for the box that says even degree. Okay, so this is my even degree. So I'm one of these 2 options, and then I'm looking which one matches up with the positive leading coefficient. Here's positive leading coefficient. So even positive leading coefficient, what does it say? The far right it's going up and the far left it's going up. So all I want us to do right now is recognize it's going up on the left and up on the right. Okay, next one, we're going to come up to this one. I'm going to circle this, and I'm going to write odd. I'm going to box this in, the leading coefficient, and I'm going to abbreviate negative. You two are together. Okay, so here we go. I'm looking for odd. These are my 2 options for odd. The leading coefficient is negative. So right here, I'm making my little chart. On the far right-hand side, it is headed down. On the far left-hand side, it is going up. Okay, are you ready? I do not need you to write down the equation for C or the equation for D. What I'd like you to have you do after I press pause is within your groups decide individually first and then talk to your team lead what's happening on the far left and the far right for example C and example D. Begin. So again, we are going to practice this because I can see that some of you are feeling confident and some of you maybe are feeling a little reluctant on what the answer is. I'm going to start by circling. I'm going to circle the degree and I'm going to write even or odd. I'm going to box in the leading coefficient and I'm going to classify it as positive or negative. I'm going to do that for both of these right now. So this is even, box in, this is negative. And now I'm going to come off to the side and I'm going to make a prediction about the end behavior. Now, end behavior is only referring to the far left and the far right. Okay, odd, positive. So here's my odd. Positive is right here. So it is going up on the right and down on the left. Next one, I have even degree, negative, leading coefficient. So even is down here. Negative is right here. So it's down on the right and also down on the left. Okay, when we look at the solutions that you've been working with for the last 3 days, synthetic division, you've been working with how do you find the solutions. And now we're going to connect that concept to what does it mean on an actual graph. So I'm going to add an extra one up here and I'm going to write solutions. Now, the only solutions you've worked with thus far are real solutions. When we start working with things that are not real, it's not going to relate to the x-axis. But right now, when you hear the words roots, zeros, x-intercepts, or real solutions, those are all 4 words you should have down. Depending on who the author of your text is, whether it's written by Mr. McFarland or it's written by AP, the AP board, it may use different words. So roots, zeros, x-intercepts, and real solutions are all interchangeable words you need to know. All of these describe when we have a graph, where does it contact the x-axis? So when something goes straight through here, we say this is degree 1. Now some books will call this linear. Some books will also say that's linear. When it bounces off, bless you, when it bounces off, so the interaction between the graph I'm going to create and the x-axis, it's either going to come from the top, it's going to come down, it's going to touch the x-axis and go directly back up, like this. Here's an example. It comes down and it bounces off. Or it may come from the bottom and it comes up, it touches it and bounces off. But either way, it's going to go back the same way it came from. So I like the word bounces off here. It bounces off the x-axis. We say this is degree 2 or quadratic. These are all different things we could use to describe it. Okay, the last one, I like to use the phrase, it snakes through. It snakes through the x-axis. Now this is going to be degree 3. Degree 3, also known as a cubic, it snakes through. So if it comes from the bottom, it comes up, and just as it's about ready to touch the x-axis, it's going to go, for a very short period of time, it's going to go horizontal, or it's going to go flat. So it's coming up, oop, it goes flat, and now it goes up again. Kind of makes that snake or a curve through. Or maybe it comes from the top, it's coming down, oh, just as it gets there, it snakes through. So although these look similar, we can see how they interact at the with the x-axis is slightly different. This is going to cut straight through it, slashes through the x-axis, and this is going to kind of curve through the x-axis. Our middle one is going to bounce off. So the answers we get will all show different type of interactions between our graph and the x-axis. I'm going to have you look up here right now, and I'm going to show you some examples. So I'm going to write this right now in this form, and you are just watching. Okay, so this is an example right now of a polynomial equation that is it's a polynomial equation that is in factored form, okay? So if you were going to look up here and you were going to tell me the solutions, these are the solutions you would tell me. You'd say there's 3 solutions. Yes, 2 of them there's a duplicate solution, but one answer is x equals 1, x equals -2, and x equals -2. Turn to your group, please, tutors, and make sure everyone understands how I was able to achieve that. Again, x equals +1, x equals -2, and x equals -2. Talk to your group. You have 15 seconds. Go. 15 seconds. I took each factor. I set it equal to 0 in my mind, and I solved. I took this parenthesis. I set it equal to 0, and I solved. I took this parenthesis. I set it equal to 0. So on your paper, please write down x equals 1, x equals 2, x equals 2. So how many times did I give you the solution x equals 1? How many times? 1 time. Thank you. 1 time. Okay, hold on here. 1 time. So it's degree 1. It's 1 time. So what should happen at 1? It should just slash through. Let's go back and look. Let's go back and look. Can everybody see over here at 1? At x equals 1, does everybody see how the function in the x-axis, how it just slashes right through? Okay, how many times did we actually describe a solution as x equals -2? Twice. We duplicated that answer. So let's go back. If it's duplicated, what happens? It bounces off. So let's come back here. At -2, does everybody see how it bounces off? Okay. Now, I'm gonna cheat here for the purpose of time, so watch this really quickly. You're going to make sure that you can see this, and I don't mind giving you this one later on, but I'm going to cheat for the purpose of time. Now, I could take time to multiply it all out, but this will help us just for the purpose of time and you having an opportunity to practice. You're gonna read to me, what was that problem? It was x -1, I believe, and x plus 2 and x plus 2. Is that correct? Okay, so this is really quickly, this is really quickly going to multiply all those out, and you're going to see why this makes a difference right now. Okay, I want you to look only right now at this right here. Look at x cubed plus 3x squared minus 4. I want you to raise your hand when you know what degree this is. Don't say, oh, hold on. Raise your hand. What degree? Hands up high. I know the degree. Okay? Turn back to your tutor, and right now tell your tutor, what is the degree? It is degree 3. Is 3 even or odd? Odd. So I'm going to come back here right now. Okay, so I'm thinking odd in my mind. Can you do me a favor, since I'm really tired still, I'm still kind of feeling icky. Can you go to your paper and just write down odd degree? Write down odd degree. Now, there may be some confusion, and the reason why is I want to know what the leading coefficient is. And some students may say there's not a leading coefficient, but there is one. Turn to your tutor. What is the value that is the leading coefficient? Go. It is 1, but I can see where some students are like, I don't see one. It's a hidden 1. So I'm going to come back here, and I'm going to actually write this down. I believe this was it, but I want to make sure when I'm tired I can easily make mistakes. Well, come on, get out of here. There we go. That looks good. Okay, so this is what I have. So this is the equation. So I'm going to come up here. You're welcome to watch, and I'm going to write odd, and I'm going to write positive. Then I'm going to make my graph. Okay, then I'm going to make my graph. Now, we already spoke, so I've already kind of cheated here. Remember, we already spoke that we know that the solutions are at 1 and at -2 and at -2, and there's a duplicate at -2. So I get to come over here. I know that there's a duplicate at -2 and there's a single answer at 1. But first I have to know what is the end behavior, because that's going to help me. So I come back over here, and I'm looking for odd, positive. So odd is right here. Positive is in this position, up on the right, down on the left. So I come back to my graph. I'm going to go up on the right and down on the left. Also, by the way, I know that it duplicates. It duplicates. Now let's go back to this graph in Desmos. There's something else you know. Does everybody see what the y-intercept is? Now look at the actual graph. So the y-intercept's at -4. How could I have also determined that without looking at the graph? Where do I find the value for the y-intercept? It's that constant. It's the value at the very end that doesn't have an x. So I'm going to come down to -4. There we go. And how am I connecting it? It's looking like this. That is a rough graph of what this looks like. And hopefully, by the way, that would go straight up. Be a little bit prettier. But it slashes right through the x-axis because it's degree 1 solution at +1, and at -2 it bounces off, and I have the correct end behavior. All right, we're going to try to put this all together right now. So the first thing we're going to do is we are going to come up here, and I'm going to circle the degree. I'm going to circle the degree. Above this, I'm going to write odd, and I'm going to box in the leading coefficient and write positive. So this was already in standard form. My handwriting is fairly messy. So it said 1x to the third plus 5x squared minus 16x minus 80. Okay, great. So I have odd, positive. Let's go back to our graph up above. Odd, positive. So here are my odds. Odd, positive is right here. Up on the right, down on the left. Up on the right, down on the left. So I'm going to come over here for myself right now, and I'm just going to go up on the right, down on the left. Everything we're working with in this chapter, especially if you're a tutor and you know more information right now than the students you're helping, everything is going to have solutions that are real. So there's no I's yet within this chapter. Okay, next up, we want to figure out what are those solutions. So this is what I know. I know that I'm going to take this, and if I'm going to figure out the solutions, all solutions have a y value of 0 because all x-intercepts have a y value of 0. So this is like our y. We're going to write 0 equals 1x cubed plus 5x squared minus 16x minus 80. And what we've been learning is we've been learning about synthetic division, where we start by writing all the factors of the constant, in this case of 80, and dividing by the factors of 1. And that may work, but you know what? I see a pattern here, knowing that my multiplication, I see a pattern here. Before I even try synthetic division, I think there's another skill that you have that maybe allows to easily identify the x-intercepts. Let's see if we can factor this. I can factor out an x squared. You're following along with me. I need one more x because x squared times x is 1x cubed. x squared times 5 is 5x squared, and I'm going to copy and paste this in back. Now, if this doesn't work, I'm going to go back to synthetic division. That's a new skill we learned in this chapter. If this is factorable, there'll be a value I can take times x, and I end up with negative 16x. So that'd be a negative 16. And if it's factorable, negative 16 times 5 would be negative 8. That works. I know that negative 16 times 5 is negative 80. How is this helping me? This is a skill, and it happens to be a skill that I can apply to this polynomial equation that allows me to solve. So I can see they both contain an x plus 5. In front of the first parenthesis is an x squared, and in front of the second is a negative 16. I'm going to provide you right now with 15 seconds to find the 3 solutions that exist. As soon as you're done, show your tutor. Ready, get set, go. 15 seconds. I've identified the 3 different solutions. Let's come up here. Solutions on a graph, real, when these numbers are real, there's no I involved, are going to translate into x-intercepts. So let's find this. 1, 2, 3, 4, good. 1, 2, 3, 4, okay, and negative 5. So I have my 3 solutions. I know that it's up on the right. I know it's down on the left. That's what I know so far. So this is a rough sketch of what this looks like. I also know one more thing looking up here. Let's say who is really listening today. What's one more thing I know about this? So turn to your partner. You have 5 seconds. Go. What's one more thing I have not put on my graph that I know? I know the y-intercept. What's the value? Negative 80. Now, there's no way I'm going to count down to negative 80. I know it's way down here somewhere, so I'm just going to give a rough estimate, like way down here. How does this help me? Well, I can see that each one of these solutions was used how many times? 1 time. So if it was used 1 time, guess what how the interaction with the line will be with the x-axis? It's just going to slash through. It's going to slash through because it was used 1 time. So it slashes through. I need to pick up that y-intercept. It comes up, it slashes through, and it slashes through again. That's a rough graph of what this looks like. Right now, example number 2. Example number 2. We're going to speed up for the purpose of time right now. So I'm going to circle the 4. A common mistake I see students make is they're going to want to write down positive or negative. We are looking at the degree because it's already in standard form, and we're going to classify it as even or odd. I'm going to box in the leading coefficient, the value in front of the variable of this term, and I'm going to classify it as negative. Now, I'm going to come over here. I'm going to make myself a very simple graph, and I'm going to refer back to that chart. So here's the chart. I'm looking for even, negative. Here's even. Thank goodness. Give me 1 second. Thank goodness that Noemi caught my mistake right away. So negative, even is down on the left and down on the right. So I'm going to come back here. I'm going to go down on the right and down on the left. That's helping me make a little prediction. Next, let's come over here and let's circle this and write y-intercepts. I know some are way down here, way down here. I'm going to have a y-intercept. All right, now it's time to determine what are the solutions, the x-intercepts, the roots, right? So I'm going to look up here, and I know that whenever I determine those, it's going to be on the y-axis where the y value is 0. So I'm always going to set this polynomial equation equal to 0. I'm going to get you started, and then I'm going to take a break for about 3 minutes and see if you can find them and then draw this rough graph. So let's start by getting rid of this negative 3 because that's just ugly. Let's see if this is even doable. If you happen to have a calculator out or you have pretty strong math skills, can you please take 39 and divide it by negative 3? Do we get negative 13? Okay, that's doable. Can you please take 108 and divide it by 3? 108 divided by 3. Anybody want to shout it out for me? 3, 1, is it 36? Is that correct? Now let's make sure I didn't make any mistakes here. I distribute, that's correct. I distribute, that's correct. I distribute. Okay, here's what I need. I need you to set this trinomial equal to 0 and see how can you solve this. I bet you can solve by factoring. Once you figure out what, good luck today, once you figure out what those solutions are, I want you to look and see how many of each solution was there. Was it a single solution? Was it a duplicate? And then that's going to help you determine what does this graph look like. I'm going to press pause. I'll be back with you. Thank you for your patience here. I'm going to come back here and see, can I factor this? 1 times 36 is 36. What two numbers multiply to give me 36 and combine to give me negative 13? I think negative 9, negative 4. You guys make sure as I'm going through this slowly I don't make any mistakes. Negative 9, negative 4. I need to split this into 2 groups. Now I'm going to set each of these parentheses or factors equal to 0. I'm going to solve. There's one, there's the other. For the purpose of time, I know this moves over, and I know this moves over, adding it and adding it. I'm going to have 2 answers, x equals positive and negative 3, x equals positive and negative 2. So I'm going to list these out. I have 2, negative 2, 3, and negative 3. I have no duplicate answers. Those are all single answers because I only see positive 2 once. I only see negative 2 once. Only 3 and negative 3 once. So here's 2 and 3 and negative 2 and negative 3. Also remember it's down on the left and down on the right. So down on the left and down on the right. Now I need to figure out what is this going to look like. Like how can I connect these? And I can't go through the x-axis any more than what I've already identified as the x-intercepts. So I'm coming up because it has to go straight through. It's a single solution. Straight through, it's a single solution. Grabbing this, straight through, it's a single solution. Straight through, it's a single solution.